Okay, this is equivalent expressions and expanding and factorising. So to start with, we're going to have a look at numbers, and then we'll go from there. So if I was going to find the area of this, we've got a rectangle, and it's like 4 meters along there, 5 and 3. If I was going to find the area of that, what I could do is find the area of this bit, and then find the area of that bit. So I could go, so my area would be, I could go 5 times 4, and then I can add it on to 3 by whatever this length is, and it's going to have to be 4 as well. So it's going to be 3 by 4. And so I can get that, well, that's 20 plus 12 is 32. And it'll be units squared, okay? Because that's how we find area, as little squares. Right, but another way I could do it is, well, I could add those two bits together. So it could actually be 4 times 5 plus 3. And so I'd have 4 times 5 plus 3 is 8, is 32 units squared. There's two ways I can do it. And so if I had another little rectangle, but this one was x there, we don't know what it is, and this was 7, and this was maybe 5, well, then I could find the area by saying, well, it's going to be 5 times x, it's going to give me that area, plus 5 times 7. 5 times x we know is 5x, and 7 fives, and 5 times 7 is 35. So, and that's an expression for that area there. I could also do it another way. I could also say that the area is in the same way that I added those two together there, I can add those two together here. So it would be the same as 5 times whatever x plus 7 is. And we don't write the times, so it would be like 5x plus 7. So really, I can say, and these are two equivalent expressions for the area of that. And I can say that 5x plus 7 equals 5x plus 35. They're equal to the same thing. And actually, if I investigated that a little bit further, if I've got 5 lots of x plus 7, well, let's have a look. If I had 5x is really x plus x plus x plus x plus x. And so 5 lots of x plus 7 is really x plus 7 plus x plus 7 plus x plus 7 plus x plus 7 plus x plus 7. I should have chosen a different number. So how many x's do I have? 1, 2, 3, 4, 5. I've got 5 x's. And then I've got 1, 2, 3, 4, 5 lots of 7. Oh, not 37, 35. Thank you. I've got 35. And so that is equal to that in the same way as that. So in maths, there's always a long way and a short way, and there's always different ways to look at it. One way that you might, if you ask your parents or something like that, they might tell you how to do it, is to go 5x plus 7. What you can do is, instead of doing this long way, you could do a short way. You go 5 times x and 5 times 7. 5 times x is 5x. 5 times 7 is 35. There's always a long way and a short way to do things, and the long way makes sense, but it takes a long time to do. The short way doesn't make any sense, and sometimes people think, oh, I don't get it, this doesn't make any sense. It's because it's a shortcut. Okay. It's not that you won't get it. Okay, let's have a look at some examples now. And so this one is asking you to find two expressions for the area. Didn't write that properly, but anyway. So as we did before, when I'm timesing that one, is going to be equal to 4 times x plus 4 times 5. That's 4x plus 20. Or I could say that is 4 times x plus 5. Okay, and so those two things are equal to each other, 4x plus 20. And you can see it's just reinforcing what we're learning over here by looking at it in different ways, kind of get relational with it. Okay, and the same way here, the area is going to be, I can either go 5 times 2m plus 5 times 3 is equal to that area. Oh, that name putting in the area. Okay, it's equal to that. And 5 times 2m, if I've got 5 lots of 2m, then I'm going to have 10 m's and 15, that. And then the other way we said to do it is you could say, well, it's 5 times 2m plus 3. You're putting those two things together. So there's my two ways for that one. In this one, we're finding whatever these sides are. And so in this one, I've gone 4 times something has got me 8n. So well, I know that 4 times 2 is going to give me 8, and I'm missing the n, so I'm going to make that n. So 4 times 2n is going to give me 8n, and 4 times what gives me 20? 4 times 5. So those two missing things there, and if I was going to write two expressions there, well, I would have 4 times 2n plus 5, or I'd have my 8n plus 20 are my two ways of representing that. Here's another one over here. Oh, this one's got nothing around the outside. Question mark, question mark, question mark. Right, well, we're looking for something, whatever's going to be over here has to be in both of those. Now I know 16 is the same as 4 times 4 times b, and I know this is 3 times 4 times a. So 4 is in both of those things, so I'm going to take 4 out. So I'm going to have, I might say that that is 4. And then what do I times 4 by to get 16b? Well, 4b. So that's 4b. And what do I times 4 by to get 12a? 3a. So I've got 3a. So this one is really going to be 4 times 4b plus 3a is the way I can write it, as well as 16b plus 12a. Okay, so here's some more practice of what we did over there. If I've got 5 lots of x plus 3, it's really 5 lots of x, 5 lots of 3. 5x plus 5 3's are 15. I've got to times both of them. And in this one, 3x times x, it's going to be 3x squared, and 3x times 7, 3 7's are 21, plus that little x there. It's not, so it's 3x's times 7 lots of 3x. 3x, 6x, 9x, 12x, 15x, 18x, 21x is what I'll have all up. Now factorising is like this sort of thing. We're trying to find, so maybe I might even, to make it easy for myself, I might even draw my little box, 4ab and 12a. Now, I know that 4 goes into 12, and there's an a there too. So I could have, there's an a in both of them, so the a can go out here, and 4 goes into both of those because that's the same as 4 times a times b, and this one is the same as 4 times 3 times a. You see, 4a is in that, and a 4 and an a in that. So 4a out here, and what's left of b, here I've got 3. So this one is going to be 4a outside of b plus 3. And I can check that by expanding. 4a times b is 4ab, and 4a times 3 is 4 times 3 is 12, 12a. So you can always check it by expanding again. You basically, if you think of factorise, is the opposite of expand. Okay, this one, another box. 6a, 3a squared. Now 6a is the same as, it's got a 3 in it, hasn't it? 3 times 2 times a. And this one is 3 times a times a. Let's do it like this. 3 times 2 times a plus 3 times a times a. Okay, what's in both of those? 3 is in both, and a is in both. So I'm going to take the 3a out the front. So in the same way, I have 3a out here. And what if I've taken out 3a, just look at the 2 here, take out 3a and left with an a here. And you can see that if I've got 3a from that one, I've got the 2, 3a, I've got the a. So you're finding this thing is something that goes into both of those. Last one. Okay, this one's got negatives in, and whenever you've got a negative, you should probably take the negative out. So we're going to make a, so really this is negative. Now what's the number that goes into both 18 and 12? 6 does. 6 times 2n minus 6 times, 2. No, 6 3s are 18. Made a mistake, that's okay. So the thing which is common is the minus 6. Now these things are actually added. This is a tricky one. So minus 6 comes out, and then what do I times minus 6 by to get minus 18? Well, it's this 3n. And now what do I times minus 6 by to get minus 12? It's going to be 2. And really, what's the sign going to be in the middle? Well, a negative times a positive is going to give me a negative. So that's going to have to be a positive number. And we can always check by expanding. Negative 6 times 3n, 6 3s are 18, 18n. Minus 6 times 2 is minus 12.